Hi, welcome back. This is lesson 18.3. In the previous two lessons we looked at the linear search, and in this lesson we'll look at an alternative search algorithm called the binary search. In this lesson we'll compare the two search algorithms, look at how the binary search algorithm works. If you're my students, we're going to act it out in class to learn a little bit more about it, and we'll write the code, the program code, to make the search work. Just to reminder, the linear search looks through every item in the array. It traverses the array using a for loop to inspect every item, and of course if the array or list has a lot of items in it, that takes a lot of loops, and so it's quite a slow algorithm. The binary search is a much quicker way to search for data, but it does have one drawback: it only works on a sorted list. So if your list is not sorted, or if it keeps changing so that the sorting gets messed up, then you can't use the binary search. However, if you do have a sorted list, the binary search offers an easy, quick way to find an item in the list. So let's just quickly review how it works. You'll get more and more familiar with this as you write more programs to create the binary search. So we've got a list, it's in sorted order. We find the midpoint of the list, and then we slice the list in half at that midpoint. And we either take the upper or the lower slice depending on which side our search term will be found. Because the list is sorted, if it's smaller than the midpoint value, we know it's in the upper half of the list, and if it's a larger value than the midpoint value, it must be in the second half of the list. So we know which half it belongs in, so we can slice the list in half and keep only the half that's got our search term in it. And then we can slice it again and do the same thing. In fact, we can keep slicing the list over and over again until we've got a list with only one item in it. And at that point, you have found your search item, or it isn't in the list at all. So if you are my student, we will act this out in class, which is quite a bit of fun. If you're not, you could have a go at trying this on paper. So let's make a random sorted list so we can test the binary search function. So this is the same commands that we had before when we were testing the linear search, but I've added a command, the list method sort, to sort the list into order. There it is. So you could copy and paste the code from last lesson, but make sure that you sort the list into order, otherwise the binary search won't work. So here's a checklist of the 3 things our program must do, and we'll work through these one after the other. We're going to slice the list in half and only keep one half or the other. We're going to keep doing that until the list has only one item left in it. And when our list is down to a single item, we're going to check whether that single remaining item is the search term, our target. So let's do the first of these, and we're just going to write the code as we go. First, we're going to slice the list in half. So to do that, we're going to find the midpoint of the list and take a slice of the list, either the values from 0 up to the midpoint or from the midpoint to the end of the list, depending on which side has got our search term in it. So let's write the code to do that. So the first thing we have to do is find the midpoint of the list. Doesn't matter what our values are, we just have to find which index number represents the middle of the list. So to do that, see if you can do that before I show you. I'm about to show you the code to do this. To find the midpoint value of the list, we divide the list in half. We take the length of the list and divide it by 2. Notice I've used integer division because the index numbers of a list must always be integers. Sometimes there'll be a slight rounding error. It doesn't matter. So we find the midpoint of the list by dividing the length of the list by 2. Now we have to compare the value found at this midpoint to our target. So the command looks like this. We find the midpoint of the list and then we're comparing the target to the value at the midpoint. So my list, square brackets midpoint, that means the value at the midpoint of the list. If the target is smaller than the value at the midpoint, then we want to take a slice from the beginning of the list up to, but not including the midpoint. If you think about it, that's logical. If the target is smaller than the value at the midpoint, it must be somewhere in the half of the list below the midpoint. Otherwise, it's in the half of the list that starts at the midpoint and goes up. So let's write the code for that. See if you can do it without looking. I'm going to show you the code in a moment anyway, so you can pause the lesson if you want. So this is the completed code for this part of the program. So we find the midpoint by dividing the list by 2, the length of the list by 2. If the target is smaller than the value at the midpoint, we replace the list, the full list, with a half list, the slice from the beginning to the midpoint. Otherwise, we replace it with a slice that starts at the midpoint and goes right up to the end. We've cut the list in half and we've only kept the half where we know the target value must be found. Okay, so that's the first step done, the slicing. Now we've got to put this whole thing inside a loop so that we keep slicing and slicing and slicing until our list is only one item. So we'll loop while the list is bigger than one item. So again, of course, at any time, if you can do this, you don't have to wait for me to show you. Pause the video, you write the code, and then you can check to see if you've reached the same solution as me. I'm about to show it now anyway. So I've put all the code that I've written so far inside a while loop, and I'm looping while the length of my list is greater than 1. And finally, so we're virtually finished now, we're going to check whether we found the value that we're looking for. There's only one item left in the list because the while loop continued until we were down to a single item. If the item that remains matches the target, then we have found it. Otherwise, the item is not in the list at all. So here is the final code. This would go below the while loop. There's only one item left in the list, and that of course would be item with the index number 0, the only item in the list. So if the only item in the list matches the target, then we can print the values in the list. Otherwise, the value is not in the list at all. So that's the completed code. To recap, in order to write the binary search, we find the midpoint of the list, we slice the list in half, and then we take the upper or the lower slice. We keep doing this until the list has a length of 1, and at this point you have found the item you're looking for, or it's not in the list at all. So in this lesson, we've evaluated very briefly the advantages and disadvantages of the binary search. The advantage is that it runs much more quickly than the linear search. The disadvantage is that it only works on a sorted list. You should understand how it works by repeatedly dividing the list until we're down to a single item, and you should be able to write code to make that happen. So I'm leaving you with some exercises. Write the binary search program and run and test it to make sure it works, whether you're looking for an item that is in the list or is not. And think if you can work out how many operations does it take. Remember, a linear search takes n operations. How many operations does it take to do a binary search? We'll talk more about that in another lesson. And finally, and again, this is more complicated, can you create a binary search function? We're going to look at that in more detail in the next lesson, so you can have a go at it in your own time. Okay, right, so next lesson we'll look at the binary search function. Bye for now.